Hello and welcome to Game Revolutions, the series where I take a video game that I started writing in high school and I add the pixie dust of experience, the nutritional yeast of education, the asbestos of excellence. In past installments, I have removed game elements temporarily so I could focus on double buffering and stack blasting and other improvements to the scrolling speed. In the last episode, I finally added the car back, and it's shiny. But the car isn't completely done. I still need to add support for... I still need to add support for... Is this a shower head? What's a shower head doing in my lap? I still need to add support for this, the joystick. We need to slide the car left. We need to slide the car right. Well, that went very smoothly. I'm sure the rest of this video will go just as smoothly. Let's add back the code that gets the joystick value and moves the car. As you may recall in the ROM, if you call getJoy, it will go ahead and figure out the values of all four axes of the two joysticks. And then the x-axis of joystick 0 will go into this location when that's done. So in the copy car routine, before we draw the car, we call the joystick routine. Get the values of the axes, fill the register A with the value of the x-axis of the right joystick. And the thresholds that I was using before were if the value is less than 5, then that means we're moving to the left. And if the axis is greater than 58, then that means we're moving the car to the right. Otherwise, there's nothing to do, and so we just get whatever the value is of the lower right-hand corner and we begin our stack blasting. If we do need to move the car, it's pretty straightforward. You grab the current offset where the car is at. You make sure that the current lower right is not less than the initial lower right. And if it is, then that means that you can't move to the left anymore, and so we won't. But if we can, we just subtract 1 from the offset, store it back, and then draw the car. Moving to the right is the equivalent.
What did I forget? What did I forget?
Let's find out. So far, so good. You might notice, by the way, we've got some weird speeding up, slowing down, speeding up, slowing down, speeding up, slowing down. Don't worry about that. We're going to talk about that later. That is not something that I screwed up in the code that you just saw. Instead, let's focus on moving the car to the right. So I'm going to move it to the right a little bit. And oh, well, I'm sure moving to the left will be okay. Yeah. All right, folks, what did I forget? Well, as you might recall from the previous video, I'm no longer redrawing every frame from scratch, including all the static regions like that green background behind the car. So that means I have to do a little extra work. When I move things around, I need to replace where they used to be with the background. So when I move the car to the left, I'm leaving a stripe of the car on the right-hand side. And if I don't get rid of that by overwriting it with the background, it's just going to stick around and look terrible. So here's the code we saw before, at least very similar code to what we saw before. There's a slight adjustment, but it basically grabs the offset where the car is at, subtracts 1, and puts it back. We're also now grabbing the absolute value of where those bytes are in the actual screen buffer. So I moved some of the code from the top down into here. So I would then have my U register ready to draw that stripe. So in order to draw the stripe, I load up my A with a green byte, and a green byte just happens to be 0. And then I store that for all the different rows where the car lives. And since everything is based on the lower right-hand corner, I'm drawing that stripe where the lower right-hand corner used to be, and then I change my U so it moves to the left, just as I changed my offset here as the car moved to the left. So that should get rid of that stripe. And for the right-hand side, similar deal, except this time as the car moves to the right, I'm leaving the left side of the car in the picture as a stripe. So since everything is based on the lower right-hand corner of the car, I need to shift to the left 5 bytes. That will give me the left byte where it used to be. Then I can advance U1 just as I advanced the offset 1. And then when we return back to the mainline code, everything is all set up and ready to go for the stack blasting.
What did I forget? What did I forget?
Let's find out. So far so good, except for that weird slow down speed up. Don't worry, we will get to that. Let's move to the right. To the left. It seems like a tiny bit better. A tiny bit better. Still pretty awful. Have you figured it out? The flashing perhaps is a hint. Remember, we got 2 buffers. So it turns out that all this code is complete garbage. As you may recall from the mile markers, we've got 2 buffers going on, and what you don't want to do is erase where the mile marker just used to be. You don't want to erase where the car just used to be. You need to erase where the car was in this buffer before we moved it for this buffer. And this is even worse than the mile markers, because at least the mile markers were always moving a fixed amount to the left every single frame. Now the car could be moving to the left a lot, a little bit. It could move left, right, left, right, left, right, left, right. We don't know where it used to be unless we remember where it used to be. And where it's going does not have much bearing on where it used to be. Maybe a little bearing, but nothing reliable. So the fix here is to keep track per buffer of where the car was. So the first thing I'm going to need to do is start keeping track of extra information per buffer. So I'm going to start off with a buffer info struct that contains just one bit of information, which is the car lower right-hand corner. This indicates where in this particular buffer the car lower right-hand corner was just drawn. And I'm going to have 2 copies of that buffer info struct. One for buffer 1, one for buffer 2. And then I'm going to have a pointer that tells me which buffer is currently being written to. I anticipate I'm going to need to add more things to this buffer info as we go along. Things like where the bullet was drawn, where the enemy was drawn. There will probably be all sorts of things I'm going to need to help with the animation, and this is going to be where I put them. They're going to be per buffer, that information. So we need to make sure that we update our off-screen buff info every time we swap buffers, and that happens at the top of the main loop. At the top is where we store which graphics buffer that we're writing into. We load X with either the beginning of graphics 1 or beginning of graphics 2, and then we write that into this graphics variable. Now what we're also doing is loading U with either the beginning of the buffer info 1 struct or the buffer info 2 struct, and then writing that into this variable here. So I can now rely on this to tell me which buffer I'm writing to, and I can use that to save and retrieve information about that writing. If we go back into the copy car routine, and we take a look at what happens when we need to move the car left or right, it's now back to very small code. We adjust the offset, we also adjust the absolute address where the car's lower right-hand corner is, But we're not doing any fix-ups here. We're not redrawing stripes of the car with the background color here, because the direction the car is moving does not determine what we will need to erase. In fact, we might not need to erase anything. If the car jiggles right-left from buffer to buffer, then in the current buffer, the car hasn't really moved, and so we actually don't need to erase anything in that case. So this is not the place to do erasing. Same with moving the car to the right. Instead, after moving the car to the left or the right, then we start doing this stuff. Now I grab the off-screen buffer info for this current buffer. I adjust my pointer to take a look at the car lower right-hand corner information in the buffer info, and I compare that with my D register. So my D register has the updated car lower right-hand corner. This is more of a global variable that tells me where the car is right now. So I'm comparing where the car is right now with where it was the last time this buffer was drawn. If the values are the same, nothing to erase. If the new offset is 2 to the left of the old offset, in other words, D, the new, minus wherever x is pointing, the old, if that's -2, we've moved 2 to the left, which means we need to erase the right 2 columns. If we moved 1 to the left, we need to erase the 1 column on the right. And if we move 2 to the right, then we need to erase the 2 left columns. And then the final thing to do would be to erase the left 1 column. This is like the else from all these ifs. Only after all that is done do we then actually do the stack blasting to draw the car. So as an example, let's take a look at the first one, car erase right 2 calls. Instead of loading A with the value of the green byte, we load D, 2 bytes worth of the green bytes. Green bytes is just like green byte, but it's 2 of them. 2 zeros. It's really the same thing, but it's a little more self-descriptive like this. And since I'm erasing the right side of the car by 2 bytes, I just start at the lower right-hand corner. U at this point is after the car has moved. So we've already adjusted U, and we just go down the line, all these rows starting where the lower right-hand corner now is. 2 bytes starting there means we're moving to the right 2 bytes and filling that in with green. If we instead needed to erase the left 2 columns, we would start at U, but we would move to the left 7 because we're moving to the left 5 to get to the left side, and then 2 more to get ready to fill in those 2 bytes with green. So -7 moves us 2 bytes to the left of the car. And we just do that for all the rows.
What did I forget? What did I forget?
What did I forget? Nothing. This is going to be flawless. All right, well, flawless other than that weird performance thing, but let's move to the right. Ooh. Hee 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 hee. Smooth. Moving. When you move the car to the left at max speed, it like the ground in it in sync. And it's like the mile markers, you can actually see them. All right, that's kind of fun to play with. Maybe I don't need to do any more to the game because this is already fun enough. Okay, so it's smooth and it moves. And by the way, the movement is exaggerated. I'm not going to let it move all the way to the right like that. I'm just doing it now to help with my testing of stuff. But let's talk a little bit about that weird performance thing. Is fast, slow, fast, slow. So what's going on there? We're going to talk about that in detail in the next video. I'm going to do a step-by-step through my performance investigation of figuring out what the deal is and how to fix it. But I will leave you with a little teaser. It actually has nothing to do with all this new code that I added. The new code I added to grab the joystick information, retrieve them, draw the car, erase the car, all that stuff. If anything, it was a catalyst. It exposed a problem that was already there, but it's not the cause of the problem. So we will talk about the cause of the problem next time. As always, thank you for watching.